Hello, we are Team 2, and my name is Emiliano.
My name is Arturo.
My name is Mauricio.
My name is Diego.
And my name is Jimena. And this is our presentation for the explanation of our code and how it works.
I'll start with a quick overview. Our MATLAB code is an F1 track simulator. First, we define in the geometry of the curvature using 4 control points and set the physical parameters, which are banking, angle, friction coefficients, gravity, car mass, and a radius threshold to define the skid zones. We also set the track width, a car and bleacher size, time step, and simulation speed. This gives the base for both the physics and the animation.
For curve calculation, for the mathematical model of the curve, we use the 4 control points to solve a linear system to get the cubic polynomial that represents the track's center line. Then we compute its first and second derivatives to get slope and the radius of the curvature at each point. From that, the code calculates the arc length and finds the minimum radius, which is critical for the safety and skidding.
Okay, so then we will discretize the curve into points along the distance of S, and we will compute the radius of curvature along the track and compare it to our maximum, which was 50 meters. And well, whenever the radius is smaller, we will mark a skid zone, which is the yellow part, using a helper function called find zones. We also compute the crash, which is the distance along the track where the car will start to leave the curve if it goes at a fast velocity.
Using the radius, the banking angle, and friction, we compute a maximum safe speed at every point in the curve, and then take the smallest one as the speed limit for the curve. For each skid zone, we built a tangent line that represents the path the car will follow when it leaves the track, along the perpendicular line to the tangent that we placed the bleachers, at a fixed safe distance using a rotated rectangle. This ensures spectators have visibility but stay outside of the skid path.
Finally, the code creates an interactive GUI with a play and stopping button, a speed input in kilometers per hour, and a reset button. During the animation, if the user's speed is below the limit, the car follows the curve smoothly. But if the speed goes higher than the limit and the car reaches the variable S crash, the code switches to a skid model. The car moves along the tangent and decelerates with kinetic friction, and we track the skid distance and mechanical energy lost. On screen, we show the track, skid zones, bleachers, and live information about speed, distance, and energy, so the user can see the physical consequences of driving too fast in a Formula One curve.
Here we can see an example where we have a speed of 94 kilometers per hour, and we can see that our car follows the track. Because it's less than our range maximum speed, which we will see in a minute that if we exceed the velocity that is higher than 95 kilometers per hour, our car is gonna skid and gonna go out of the skid zone, crashing, but not with the viewer's zone.
And that has been the explanation for our code. Thank you for your attention.
Bye.
Bye.